Okay, hi everyone, welcome back to my YouTube channel, the app Math Aficionado. Today's video is going to be our video on chapter number 4, which is discovering the fractions and the factors. So, this is chapter number 4, discovering fractions and factors. Okay, so here in this chapter, we have the list of 6 lessons. So we have 6 lessons in this chapter, which are number 1, monomials and adding or subtraction of polynomials. Monomials and addition or subtraction of polynomials. The second one is powers and exponents. Third is multiplying polynomials and binomials. Number 4 here is factorization and prime numbers. Number 5 here is finding the greatest common factor. And the last but not the least, which is number 6, finding the least common multiple. Finding the least common multiple, which is LCM. Okay, so this chapter basically covers these 6 lessons. Okay, now we'll be covering these lessons one by one. So let's start with the first lesson, which is monomials and addition or subtraction of polynomials. So let's start with lesson number 1, which is monomials and addition or subtraction of polynomials. Okay, so now here I see the term monomials, right? So what exactly is monomial? So a monomial is basically a number, a variable, or a product of a number and a variable. So monomial is basically a number, a variable, or a product of both. Okay, where all the exponents are non-negative whole numbers. So here the exponents that we have in the case of monomials are non-negative whole numbers. So that means the exponents cannot be negative. Clear? I'll give you the example of a monomial. So the example here is 42, which is a number, 5x, which is a variable, 5x, which is a multiplication or which is a product of a number as well as variable, right? So here if you see, this is a number and this is a variable, right? This is only a number, correct? Now the third example that would be is 14x square. So now here 14 is a number, right? X square is a variable, right? And what is the exponent of a variable? It is non-negative, right? Another example would be 2pq. So here if you see, 2 is a number, p and q are the product of two variables. correct? So we have seen that monomial is basically the number, variable, or the product of both, provided the exponent that we have in the case of a variable is a non-negative whole number. Clear? Now I'm going to give you the examples of monomials. The examples of which are not monomials. For example, let's say 4 plus y. Now here we have this as a number, this as a variable, right? But there is no product in between them. Rather, we have addition between them. So this is not the case of monomial. Okay. Similarly, if we have 5 over y, so here we do have a number. This is a variable. Okay. But rather than having the product between them, we have a division. So this is also not a monomial. Clear? Now, the third example is 14 to the x. Now here I see 14 is a number. There's no doubt about that. X is a variable. But this combination of both is not a monomial. Why? Because we have an exponent which is x. And we know that a variable can take a positive as well as negative value, right? And we have to make sure of the fact in the case of monomial that the exponent that we have is a non-negative whole number. Okay, so this will not work in the case of monomial. The last example would be 2pq to the negative 2. Now here this is a number. These are variables, but I see a negative exponent, right? Which is not possible in the case of monomial, so we reject this as being a monomial. Okay, so these all examples that I just gave you, they don't fulfill the criteria of a monomial, so not monomials. Okay, some of the other issue was there, that's why these don't fulfill the basic criteria of monomials. Okay, so next that we are going to cover is the degree of a monomial. Now, how do we define the degree of a monomial? So it is basically the sum of the exponents of all the included variables. So that means whatever variables we have in a monomial, either there is one variable or multiple variables in product. So what we have to do is we have to simply add the respective exponents, and that's how we are going to get the degree of the monomial. Okay, now when it comes to constants, okay, they are also treated as a monomial, because we know that the monomial can be a number, right? So constants, when we take that as a monomial, so they have the degree of 0. So have the monomial degree as 0. Clear? Why it is 0? Because that is a constant, that is a number, and we don't have a variable. So if it is 1, we treat that as a degree of 0 to a variable. Okay, so for example, let's say if it is 4, so we can write this as 4x to the 0, right? So this becomes your degree in that case. Now this was a constant, correct? Okay, so now I'll form a table wherein I'll be listing few monomials and the respective degrees. Let's see what the table is. So on the left we have a monomial, on the right we have the degree. Okay, so the first example is 42, which is a constant, so degree will always be 0, because we know that the constants have the monomial degree of 0. We just studied above, right? The next is 5x. Now here x has a degree of 1 and 5 is a constant which is assumed to have a degree of 0, because it's a 0 degree monomial. So that's why it's 0 plus 1, and that is equal to 1. Okay, the next is 14x square. Now here 14 is a constant, so that is going to be taken as 0, and then we have square to the x, right? So that will be 2, so it will be 2. The last, which is 2pq. Now here the constant has 0, then we have 1 to each of them, so it is 1 plus 1, and that is 2. Okay, so this is how we calculate the degree of a monomial, and I've listed the 4 monomials as an example to understand this better. Clear? Okay, now let's come to polynomial and how polynomial is different from a monomial. So a polynomial, as opposed to the monomial, is basically a sum of monomials where each monomial is called a term. So when it comes to polynomials, it's basically the sum of multiple monomials where each monomial is treated as a term. Okay, how do we define the degree of polynomial then? Degree of the polynomial is the greatest degree. Now since we have multiple terms, so we'll be taking the highest degree term. Okay, and that's going to give us the degree of the polynomial. So degree of the polynomial is the greatest degree of its terms. Clear? So the degree of the polynomial is basically the greatest degree of all the terms. Now when we write a polynomial, so we sort it in a descending order of the degrees. So we sort basically the terms in the descending order of the respective degrees. I'll give you the example to each of these, okay, and that will make it more clear. So when I say the descending order of the respective degrees, so that means the term with the highest exponent of the variable first, and then decreasing from left to right. Okay, so that's how we arrange them in a descending order of the respective degrees. I'll give you the example. So the example here would be 4x to the 5 plus 2x square minus 14x plus 12. So here if you see, this is the highest degree, right? And then we have number 2, then we have 1, and then we have 0. Okay, why I'm writing 0 here? Because a constant is taken as 0 degree monomial. Clear? So that's how we represent a polynomial wherein the terms are arranged in the descending order of the respective degrees. How do we treat? How do we? Okay, so now if I have to write the degree of this polynomial, so what is the highest degree here of all the terms? So that is 5. So degree here will become 5. Clear? And also, as you can see, so here we have a polynomial. Here we have a polynomial which is basically the sum of many monomials, right? So now here each term is basically treated as a monomial. Clear? Or is a monomial, not treated as, it's rather a monomial. Okay, so we have the sum of multiple monomials here, and that forms a polynomial. Now what is the next scenario is, now based on number of the terms, or you can say number of the monomials that we have as a part of a polynomial, we have different categories of, or we have different labels to them. So suppose if polynomial consisting of two terms slash monomials. Okay, so then we call that as binomial. Okay, so the polynomial with two terms is known as a binomial. Similarly, with three terms slash three monomials, we call that as a trinomial. Clear? So the polynomial, so suppose if here in the above case, if I take that same example, so let's say if it was 4x to the 5 plus 2x square. Now here we have two terms, right? So this is a binomial. Okay, similarly, if we take the three terms, so that is 4x to the 5 plus 2x square minus 14x. So now here we have three terms. So that is going to be treated as a trinomial. Clear? So that's what I was explaining you about. Okay, now we will see a few examples wherein we will be figuring out the degree of the polynomial, how do we rearrange them, okay, and something like that. So we'll see a few examples now based on what we have studied so far. So the first is, what is the degree of the following polynomials? So the first polynomial that we have here is x squared plus x. Now if you see carefully, the first term has the exponent of 2, right? And the second term has the exponent of 1. When we don't have any exponent, so we treat that as 1, right? So what is the highest degree here? 2. So that becomes your degree of polynomial. And what is it basically? A binomial, because we have two terms. So here the degree of polynomial is 2. Clear? Similarly, let's take another example. So the second one is x4 plus x squared plus x. Now here I see three terms, right? So this will become a trinomial. Also the highest degree that we have here is 4. Or you can say the highest exponent that we have here is 4. So that becomes your degree of polynomial in this case. So degree of polynomial in this case is 4. I hope that is clear. Okay, so whatever is the highest exponent or the degree of a term, that becomes the degree of the polynomial. Now next is, how do we basically add or subtract the polynomials? So next is addition or subtraction of polynomials. Okay, so now we are going to study how do we add or subtract the polynomials. Now addition we have already seen. Okay, we simply add the terms of the we simply add the multiple monomials or the multiple terms, and that's how we have a polynomial. Now when it comes to addition of the polynomial, so we'll be adding two polynomials together. Okay, similarly in the case of subtraction, we will be combining the two polynomials with the negative or the minus symbol. I'll give you the example. Let's first discuss the addition, wherein you simply add two polynomials together. For example, let's say if you have 4x plus 8, which is one polynomial, and then the another polynomial is 3x plus 2. So here we are adding these two polynomials. Okay, so when I add them, so opening the brackets, so this is going to be like this, Now I'll be combining the like terms. When I say the like terms, so these two are the like terms, which are basically the variable terms, and then these two are the constant sums, so they are also treated as their respective like terms. So we'll combine the like terms together. So that is going to be 4x plus 3x and 8 plus 2. This is 7x and this is 10. Now this is how I add the two polynomials. Clear? So what we basically did here is we had two polynomials, we opened the brackets, we combined all the terms of the two polynomials, and then we combined together the like terms from both the polynomials, which were 4x plus 3x and 2 and 8. Okay, that's how we figured out the sum of two polynomials in this case, and that is 7x plus 10. Clear? Now I'm going to take next the example of subtraction of polynomials. So now when I say subtraction of polynomials, so that is 4x plus 8 minus 3x plus 2. So here you see we have two polynomials and there's a subtraction symbol in between them. Now what we are going to do, so we are going to exactly follow the same process. We'll be opening the parentheses, which are 4x plus 8. Now negative gets distributed to each of them while opening the parentheses, so this will be negative 3x, negative 2. Now I'll be combining these two like terms and these two like terms. Okay, so this will be 4x minus 3x and 8 minus 2. So 4x minus 3x is x and 8 minus 2 is 6. So this becomes my final answer. So that becomes my subtraction of the two polynomials, and that is giving me x plus 6. I hope the addition and the subtraction of the polynomial is clear to you now. If there is any doubt, you can let me know. And so if there is any doubt or anything that needs more clarity, so you can possibly let me know in the comments of the video. Okay, we'll take one last example and then we'll move to lesson number 2. Okay, so the next example that we have here is x squared plus 3x plus 8. So this is your first polynomial, and the other one is 3x squared minus 2x plus 4. Okay, so now here what we are going to do is we have two polynomials, right? We are going to open the parentheses in the first step, so let's do that. X squared plus 3x plus 8 and then 3x squared minus 2x plus 4. Now it's very clear, right? This is addition that we are performing with the two polynomials. Now here when we combine, so these two are the like terms, these two are the like terms, and these two are the like terms, right? So let's combine them respectively. So x squared plus 3x squared, then 3x minus 2x, and then 8 plus 4. So x squared plus 3x squared is 4x squared, 3x minus 2x is x, 8 plus 4 is 12. So this becomes your sum of the two polynomials that were given to you, which is 4x squared plus x plus 12. Okay, so this lesson was all about figuring out what polynomial is, how do we define the degree of the polynomials, what are the examples of non-monomials, right? What are monomials? How do we form the polynomials from the monomials? So wherein each term of the polynomial is treated as a monomial, right? Or each monomial is acting as a term in the polynomial. Okay, then we studied about how do we form the polynomials from the monomials, what exactly is the degree of the polynomial, right? And how do we segregate, or how do we label them differently when it is two terms or the three terms in the polynomials as binomial and trinomial respectively. Then we have seen the addition and the subtraction of the polynomials, okay, wherein we combine them and open the parentheses and combine them, and then we combine the like terms, and that's how we figure out the addition and the subtraction. Okay, Also, we have seen that in order to write a polynomial, we usually write them in a descending order of the respective degrees of their terms, right? And the highest degree is taken as a degree of the polynomial. So that was all about in this lesson number 1. Now let's move to lesson number 2. Okay. So lesson number 2 here is powers and exponents. Powers and exponents. Okay, so now you must be having a basic idea of what exponent is, right? Now we'll study in detail about powers and exponents in this lesson. Okay, so now if we have to calculate the product of two numbers, which is 5 and 5, so how do we write it as? 5 times 5 is 25, right? So how do we write it as? In the form of exponent, so that is written as 5 square, right? So what exponent here is basically, this is your exponent, right, which is 2, which represents the repeated multiplication of the same factor, and that is also known as power. Okay, so exponent and the power are basically the alias to each other. Now what is 5 here? So 5 is taken as the base. It's a base number to which the exponent is raised. Okay, so 5 is treated as base and 2 is treated as a exponent, and the exponent corresponds to number of times the base is used as a factor. So when I talk about the factor here, so I am talking about the base indeed. Okay, so how many times this base is getting repeated in multiplication or the factor is getting repeated in multiplication is what forms the exponent. Clear? Also we write it as power. Okay, now I'll be listing few exponents or the powers. So the first one is 3 to the 1. So we write it as 3 raised to first power. Okay, so that is basically equal to 3. Okay, the second one is 4 square. So 4 is 4 to the second power, or 4 squared, and that is equal to 16. I mean 4 times 4, which is equal to 16. 5 cube, 5 to the third power, or we can write it as 5 cubed. So 5 times 5 times 5, which is equal to 125. The last is 2 to the 6, so 2 to the power of 6. Okay, so this is 2 times 2 times 2 times 2 times 2, and that is 64. Okay, so this was your table of the representations of different powers. Clear? Now the next example that we are going to take is you have to write these multiplications like exponents. So you have to write these multiplications as exponents. So the first multiplication that we have is 5 times 5 times 5. Now here your base, which is 5, is getting repeated 3 times, right? So this is basically written as 5 to the 3. So exponent forms, exponent that gets formed here is 3. Similarly, for the second example, 4 times 4 times 4 times 4. So here 4 is getting repeated 5 times. So it will be 4 to the 5. Okay. The third is 3 times 3 times 3 times 3. So here 3 is getting repeated 4 times. So it will be 3 to the 4. Okay. So this is how we represent the powers over the exponents. Now there may be a scenario when the two exponents or the two powers are multiplied or divided, right? So next we are going to see is the multiplication of two powers or division of two powers. So let's head towards that. So the next we are going to see is multiplication. Now if the two powers or the exponents, whatever you want to say, have the same base. Now the condition here is that they need to have the same base, okay? Otherwise you won't be able to perform the multiplication or the division. So they need to have the same base, okay? Then only it makes sense. So if two powers have the same base, then we can multiply the powers, okay? So then we can multiply the powers, and when we multiply two powers, we basically we basically add their exponents. So when we add two powers, so we basically add their exponents, okay? For example, if I have to represent this, or otherwise let me write it in general form first, then we will see a few examples. So the rule here is, let's say if you have one power as x to the a, another one as x to the b. Now here if I see clearly that I have the same base, right? So if the base is same, so we can obviously multiply the two powers or the exponents. So x to the a multiplied with x to the b is going to give us x to the a plus b. So I basically added the exponents, or you can say the power, okay? So this is how we perform the multiplication of two powers. Now let's take a realistic example. So that is going to be 4 square multiplied with 4 to the 5. Now here if you see carefully, so this is a same base, right, which is 4. Now when you multiply these two, so what do you get? 4 will be having the added exponent, which is 2 plus 5, and that is 4 to the 7, okay? So we basically added the exponent because we had the same base, and that's how we multiply the two powers over the exponents. Clear? Similarly we are going to do the same in the case of division. So next will be division of powers. Now here again the same condition is going to hold, which is we need to have the same base. Then only we can have the division of the powers. So if the two powers have the same base, then we can divide the powers. And when we divide the powers, what we basically do in that case, we subtract their exponents. When we divide powers, we subtract their exponents, okay? So I'm going to write the rule next. So rule here will be x to the a over x to the b, which is basically divisions of two powers. So what we are going to do here is we'll be subtracting their exponents, which is x to the a minus b, okay? The example is going to be like this: 4 square over 4 to the 5. Now here you see that the base is same, right, which was a prerequisite. The base is same, so that's how we are able to perform the division. So now while simplifying, so this is going to be 4 to the 2 minus 5, which is 4 to the negative 3. Okay, so here we basically, since the division was there, so we subtracted the exponents, and that's how we got 4 to the negative 3. Now you must be wondering, we have got a negative exponent, so how do we simplify that further? So a negative exponent is basically the reciprocal of a positive exponent. So let's say if it is x to the negative a, so that can always be written as 1 over x to the a. Okay, so a negative exponent is the same as the reciprocal of the positive exponent. Okay, so a negative exponent is basically the reciprocal of a positive exponent. So now this can be written as 1 over 4 to the 3. Okay, by making use of this rule. Clear? So whenever there is a negative exponent, and if you want to simplify that to a positive exponent, so you can take the reciprocal, and that's how you'll be able to write it in a form of a positive exponent. Okay. Now the next scenario that we have here is when we raise a product. Let's say there are product of two variables, which is x and y, and we are raising that to exponent a. So in that case, what we basically are doing is we are raising each factor with the power. Okay, by each factor I mean to say this one. This is your factor number 1, this is your factor number 2. Okay, so when we raise the product of two factors, or when we raise a product to a power, so we are basically raising each factor with a power. So that means it will be x to the a times y to the a. Okay, so the product was raised to a power, and hence we are raising each factor to the same power. Clear? Let's see the example here. Example here would be 2x to the 4. Now here we have the product of 2 and x, and that is raised to the exponent of 4. Now that means each of the factor will be raised to the exponent, and that is going to be 2 to the 4 times x to the 4, which is 16 x to the 4. Clear? So that's how we multiply, or that's how we raise a product to a power. I hope that makes sense. Okay, the next scenario that we have is the rule for the power of a power and the power of a product can be combined into the following rule. So we have studied two rules above, right? What were those two rules? So one is when a product is raised to a power, okay, and one we already know when we have a power of a power. So power of a power. So I'll first write the rule, and that will make it more clear, and then we'll take one example based on that. So here, let's say if we have something like this, x to the a multiplied with y to the b and whole raised to z, and whole raised to z. Now here I see we have a product, right? We have a power here, so a product is raised to a power, right? And also, since we inside the product we also have the powers, so can we take this thing as power of a power, right? So we basically have combined the previous rule, which was a product raised to power, with power of a power. Okay, so now here what we are going to do is this a gets multiplied with the z, so that is going to give you x to the a times z, multiplied with by b will get multiplied with z, so y will be raised to b times z. This is how this rule works. Let's take the example to understand this more. Let's say if you have x to the 3 and y to the 4 whole raised to 2. So now this 2, okay, so now here we have a product that is raised to a power, so each factor is going to be raised with to the same power. So what are the each factors here? X to the 3, and that will be raised to 2, and instead of writing it this way, we will write it the other way. So it will be x to the 3 times 2, and then y raised to the 4 times 2. So this will be x to the 6 times y to the 8. Clear? So this is how we have combined power of a power with a product raised to the power. I hope that is clear now. We'll take one final example. We'll take one final example in this case, and then we'll close this lesson and we'll move to the next lesson. Okay. So the example that we have here is x squared multiplied with y cubed multiplied with z to the 5 whole to the 3. Now this is the example based on the last concept that we studied. Okay, so what we are going to do is we'll be writing, each factor is going to be raised with the power. So that is going to be x to the 2 times 3 times y to the 3 times 3 times z to the 5 times 3. So this is basically x to the 6 times y to the 9 times z to the 15. That's how we figure out the answer. Okay, clear? So this was all about this lesson. I hope the things that we discussed is making sense. Now let's move to the lesson number 3. Now this was a big chapter wherein we had 6 lessons. So I'm going to cover 3 lessons in this video, and then I'll be making the part 2 of this video wherein we'll be covering the next 3. Okay, it's going to be a long video if we accommodate all the 6 lessons in the same video. So rather let's split this to part 1 and part 2, and wherein each part will have the 3 lessons of the same. So now since we have already covered 2, so let's cover number 3, the lesson number 3, and then we can close this video, and then we'll be having the part 2 which will have the next 3 lessons of the chapters. In order to refer to the list of the lessons, I have discussed that in the beginning of this video. You can refer to that. Okay. Now what is lesson number 3? So lesson number 3 here is multiplication of polynomials and binomials. Multiplying polynomials and binomials. So now when it comes to multiplication of polynomials and binomials, so we have already studied them individually, right? What are polynomials, what are binomials? So polynomial, when a polynomial has 2 terms, so that is what is known as a binomial, right? Now we'll be studying the multiplication of both of them in this case. Okay, before coming to binomials, let me show you how do we multiply a polynomial with a monomial. Okay, how do we multiply a polynomial with a monomial? Then we'll come to the multiplication of polynomial with a binomial. Now when it comes to multiplication of a polynomial with a monomial, so we basically try to explain that using area of a rectangle. Why do I say that? I'll show you. So we basically make use of the area of the rectangle in order to explain the same. Okay, let's assume there's a rectangle, okay, wherein the width is 5x minus 4 and the length is 5x. Okay, now we know that, so this is your rectangle. Now when we know that the area of the rectangle is given as breadth times height, or you can say length times width, right? Whatever you want to say, you can take it as length times width. Now what is length here? Length is 5x. What is width here? 5x minus 4, right? Now you will distribute them. So this is going to be 5x times 5x minus 5x times 4, correct? And this will be, what is 5x times 5x? This is 25x square. And what is 5 times 4? 20, and then there's x. Now here you see that we have multiplied 2. Okay, what is 5x here? This is a monomial, right? What is this? Either you can take it as binomial, I mean in a specific case, or you can also take it as polynomial, correct? So you are multiplying a monomial with a polynomial in this case, right, to be precise. And the product that we have got here is 25x square minus 20x. Now when we distributed 5x to each of them, so this is from the distributive property, okay, wherein the outer term was distributed to each of the inner term. Okay, if I have to explain that in detail, so that is going to be, let's say if there is outer term which is a, and then there is addition of two inner terms, so this a is going to be distributed to each of them, so it will be a times b plus a times c. Clear? That's what I've done here. 5x was distributed to each of the inner terms, which was 5x and 4, and that's how we go 25x square minus 20x. Now this was when we applied the distributed property with respect to the terms. We can also have with the numbers. So when I say with the numbers, so that is going to be 5 multiplied with 2 plus 6. This is example, so this 5 is going to distribute to each of them, so it will be 5 times 2 plus 5 times 6, so which is 10 plus 30, and that is 40. Okay, so this is your example of the distribution or distributive property with respect to numbers. Now when it comes to with respect to variables as well as numbers, so in that case, let's say if you have 7x plus 4x, so you can take x, which is a common factor here outside, and then you can have 7 plus 4, okay, which is 11x. Now here this is basically the reverse process of what we have done so far, but what needs to be understood is here we are trying to apply the distributive with respect to variables and numbers. So if you see, outside is a variable, right, and inner terms are numbers, so we are trying to apply the distributive with respect to both of them in this case. Now as we have seen, we use the area of the rectangle in order to explain how you multiply a polynomial with a monomial, right? Similarly, we can also use the area of rectangle to explain the multiplication So here we basically are talking about multiplication of two binomials. Okay, so we can use the area of the rectangle in order to explain the multiplication of two binomials also. Clear? I'll give you the explanation here now. So the explanation would be, let's take a rectangle wherein the width is 2x plus 2, it's a binomial. 4x plus 3, this is also a binomial, right? Now we know that the area is equal to length times width. What is length here? 4x plus 3. what is width here? 2x plus 2, right? Correct. Now here we have two binomials and multiplication. So how do we do that? Now obviously we will have to use the distributive property. So either we distribute the first binomial with respect to each term of the second binomial, or we distribute each term of the second binomial with respect to the first one. It's up to us. Okay, so let's do that. Let's distribute 4x to each of them and then 3 to each of them. So this is going to be 4x times 2x plus 2 plus 3 times 2x plus 2. Okay, so I have basically used the distributive property here. Now this is again another distributive application. 4x will be distributed to each of them, so this will be 4x times 2x plus 4x times 2, and similarly 3 will be distributed to each of them, so it will be 3 times 2x plus 3 times 2. So this is 8x square, this is 8x, this is 6x, this is 6. 8 and 6 can be combined, so it will be 8x square plus 14x plus 6. This becomes your product of the given two binomials. Clear? So that's how you multiply. I mean, obviously this was a small lesson, but here we have studied the multiplication of polynomial with a monomial. Also we have studied the product of two binomials, and both of them could be represented by making use of the area of rectangle. A final example and then we'll close this lesson. The final example here is when we multiply 3x plus 4 with x square minus 2. Now if you see carefully, here we have the product of two binomials again. So this is a binomial and this is also a binomial, right? So when I multiply them, so this will be 3x distributed to first and second, and then 4 distributed to each of them. So 3x multiplied with x square plus 3x multiplied with negative 2, and then 4 multiplied with x square, 4 multiplied with negative 2. So this will be 3x to the 3 minus 6x plus 4x square minus 8. So now as we know that we always write polynomial in the descending order of their degrees of terms. So what we are going to do is we will bring this one here and this one back. So it will be 3x cubed plus 4x square minus 6x minus 8. So now here in this polynomial you have the degrees of each term sorted in descending order of their degrees. Clear? So this becomes your multiplication of the given two binomials. I hope this is making sense. Now this was your lesson number 1. This was your lesson number 3. Now we have 3 more lessons, and that we are going to cover in the next part of the same video. Okay. So I hope everything that we discussed in this video is making sense. In case you have any doubts, you can always post me those doubts. You can always post those doubts in the comment section. Okay, so that's all for today. If you found this video helpful, please don't forget to like, share and subscribe to my channel. Your support is what motivates me in creating this content with love and dedication. I would love to hear your thoughts in the comment section. Please let me know in the comments how you like this video, and if any suggestions you have, you can let me know. Okay, so that's all for today. Thank you so much. Bye.